In this lab activity, we're going to convert a carbonate to a halide through a chemical reaction. Notice the balanced chemical equation and our resulting products of sodium chloride, liquid water, and gaseous carbon dioxide. Apologies for the audio, the microphone is fairly inconsistent, but let's carry on here. As you review the pre-lab questions, do take special note of the theoretical amount of halide that you'll create based out of your carbonate that you start with. You're going to use a similar process at the end of the lab activity to calculate your percent yield. You'll notice the post-lab questions and the data recording sheet at the end of the linked lab activity page. So the first thing we're going to do is make sure that we have all the equipment that's listed as materials, and then we're going to give a very thorough check of our crucible for any cracks or deficiencies so that we can make sure we're not going to get injured or have any kind of breakage or spill during the heating process today. So according to the procedures, the first thing we're going to do here is heat our crucible. This will get rid of any water in it or any remnants that might be in it as well. After about 5 minutes, we're going to remove from the heat and let it cool. While it's cooling, we're going to go ahead and find our sample of carbonate. Note that the lab report activity asks us to find a sample between 0.5 and 0.6 grams. So this seems to be a sufficient amount. The next thing that we're going to do is get the mass of our crucible. And so you'll see here that we put the lid on and we will now record the mass of the crucible. The next thing we need to do is add our sample of carbonate to our crucible with lid. And then we're going to record that mass of the crucible with the sample of carbonate in it. In order to conduct our chemical reaction, we do need our carbonate to be aqueous, and so we will add some distilled water to it, just enough to make it slightly aqueous. This is not going to, the water is not going to be an active participant in the chemical reaction. So now that it is aqueous, we're going to go ahead and start the chemical reaction by adding a very controlled bit of hydrochloric acid. But remember, we need this hydrochloric acid to be in excess. So we're going to complete the chemical reaction with HCl. We'll even add a little bit more HCl just to make sure that all of our reactants for the carbonate have been completely reacted with the hydrochloric acid. So our hydrochloric acid effervesced pretty rigorously with our carbonate in aqueous solution, but the bubbles have essentially stopped, so we'll give it a quick swirl. We'll add a little more excess hydrochloric acid just to ensure that we've completed the reaction. And then the next step in the procedures is to heat the crucible. Remember, our products for this chemical reaction were carbon dioxide gas, which we just released. You saw all of the bubbles. plus water in a liquid form, and then sodium chloride acting as our halide. And so we want the sample of just the halide, so we're going to begin heating to remove the liquid H2O. And this is a pretty long process, so we continue to heat. And we could have got the crucible perhaps a little bit closer to the inner cone of our flame, but we wanted to kind of control the heat here because whenever it's in a liquid format, it's similar to boiling pasta. It can potentially boil over, and if it boils over, we're going to lose part of our salt sample, and we don't want to do that. So we're controlling our boil here, controlling our steam here, and instead choosing to let it cook longer. And so again, this heating process takes several minutes. We're going to heat it very vigorously here towards the end, just to really get any of the additional water out. And then we will let it cool. It does take about 10 minutes to cool this crucible to room temperature. And then we'll record the mass of the halide and the crucible, so make sure to record that as well. We need to repeat the heating and cooling process here just to ensure that we don't have a hydrous salt inside of our crucible still. So we're going to heat it very vigorously. What happens is that salt starts to crystallize anywhere that there was water solution or an aqueous solution, and so there is a tendency to get some water trapped in between the crucible walls and the crystals that form over it. And so heating it a second time here, we may see a little bit of steam, we may see a little bit of, or hear a little bit of popping as any of that residual liquid water becomes gaseous and escapes through the salt crystals. And so on occasion here you may see a little bit of water vapor when that happens. But we're going to continue to heat this for about 15 to 20 minutes again, just to make sure that we have all of our water out of our sample before we get the final weighing for the salt and crucible. So again, after heating it for several minutes and very vigorously at this point, we go ahead and let it cool. The cooling again takes about 10 minutes. And then we're going to do our second weigh-in of the halide and the crucible. And we get a pretty consistent reading, so that's a good thing. And so just for a visual here, this is our halide or sodium chloride that we created. Thanks for watching.